Hey team, welcome back to my channel. This video has chapters in case you want to skip around. The source code for this video is available on my GitHub account. Go to github.com/softwareNuggets, then use the repository assembly. Look for lesson 2. Let us dive into lesson 2 assembly language. Open up your favorite browser, go to mycompiler.io. Drop down combo, look for assembly language. Now keep existing code? Nope. We want to replace with an example. Notice here, out of the box, we get a hello world example. Now don't worry about this version. Our version will be more clean and you'll learn quite a bit. Let's do it. Now before we dive into hello world, let's do a refresher with lesson 1. This program only called sysexit. Remember, we loaded 60 into the RAX register, 0 into RDI register, and then we called syscall. Now notice the same code is at the bottom of hello world. In lesson 1, I showed you syscall_64 TBL. That's where we get the system call number. And syscall.h, that's where we get the signature for the function. I now have to introduce you to one more, and it's going to be called Syscall Table. Let's take a look at that. Open up your favorite browser and type in Syscall Table. Search for that. Click on Chromium OS Docs. Scroll down till you see this table. Look for your architecture. Here you can see which register we will use when we set the system call number, the return value, and the argument registers that we will use. This second table makes it easy to identify the system call number for the function you'll want to use, as well as the parameter names and registers that you will use as well. In today's lesson, we're going to be using system call name write. So notice that it has 3 input parameters. We'll be using RDI, RSI, and RDX. If you're new to assembly language, notice when we say 1 and 60, that is not obvious. How can we make a small change to our program to just add some clarity? So what I like to do is I like to say define syswrite1. And notice here where I have defined this as 1, I'm just going to replace that with syswrite. Let's now modify line 24. Replace 60 with the preprocessor directive sys_exit. I think we can both agree using symbolic constants improves readability. Can we clean this up some more? We sure can. What is on syswrite, what is the first parameter? Why is that the value 1? As you can see here on line 17, I went out and got the function signature, and I got that from syscall.h. I pasted it in here so I could understand what my parameters are. I already know what registers they use, but I kind of need to understand this. So what is FD? Well, FD is the file descriptor. Now I know I'm not using a file, but I can use standard in, standard out, and standard error. On line 19, the statement move RDI, 1, we know we can improve readability. Let's use a StdOut constant. So we created our preprocessor directive, define standard out as 1, and then we can take the name and put it down here and replace that 1. And that should make that a little clearer. Let's now look at the next statement. We're going to say move RSI, message. Now where did message come from? Well, we have to go back up to section data. Now section data is a segment used to declare and initialize data that our program is going to use. So here is the name of our label. Now I'm using the term label, not variable. When we declare a label like message and associate it with a value, message indicates the starting address of where this data begins in memory, just the starting address. Think of message as a signpost that marks the starting memory position of hello world and the new line. So all of this is up in memory, but this just points at where this begins. Now the starting address in memory is the only thing that we know about this data. We don't know about how many characters in length this is. Then we look at the data type. This right here is a data type byte. Now that means like each of these characters takes up 1 byte. Now down here on line 22, the third parameter, notice it's of type size t, count, and it wants the number of characters. So here you can see that we'd have to maybe like go out and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13. So actually, this takes up 13 bytes of memory. So MSG just points at the beginning, has no idea how many characters, and we're going to put that in RSI. Then we're actually going to manually go count the number of characters and put that into RDX. Then of course we're going to call system call, and that will go to StdOut. Let's go ahead and run this and see what happens. So notice we get hello world. Now you may be wondering what this 0xa is, and all that is another character that's inside of this data byte, but 10 represents the ASCII character 10, which is line feed. As you can see on line 12, I have commented out message, and I have rewritten message just differently. So instead of it being a string with a 10 character appended, I have them all as individual bytes. So notice the H all by itself, the E all by itself, all the way to the carriage return. Now when I execute this, notice I'm still picking up 13 characters. Let's go ahead and execute this and see what happens. So notice we get hello world. Now, if that wasn't enough, I'm going to show you one more way. Here, I just have individual bytes. So 72 is capital H. And how do I know 72? These are the ASCII values for each of these characters. So here I'm saying message, the data type, all of our characters, including the line feed character. And now I'm hoping that this makes sense. Let's now take a look at this length. This is the total number of characters that make up the data. Remember, I counted off each of them and there's 13. But what if I come in there and I put in like 3 characters and a space? Well, this is no longer 13 bytes long. And when I execute this, you can see world is truncated. Now, how would we make this dynamic to create the string length of this? Let me show you how I would do that. The current location counter, the dollar symbol, is the value used during the assembly to keep track of the current memory location where the assembler is placing the instructions or data. So what I can say here is MSG length. Now what does that equal? Well, EQU dollar, I just told you what that meant, minus MSG. Now MSG, that is the starting position of this in memory. Dollar is the current location counter. So I can't put additional lines in here and expect to get this line. This line has to follow this. Now these are comments and they don't get compiled. So this right here will go get the next offset, and I'm taking that next offset minus where it begins, and that should give me the string length. Then I'm going to take message length, and notice where I say 13, I'm going to replace that, I'm going to run it, and notice we get hello world. Isn't that nice? Is this still on? Hey team, welcome to my channel. I'm Scott Johnson. I'm the guy that makes all these videos. So we just finished watching Hello World. This is a program that normally is started on almost all programming languages. And now you have that under your belt, you should be able to do Hello World in assembly language. You're one of few people that could actually do this. Take pride in that. Now, if you have any questions or comments about this program, Hello World in assembly language, please leave them below. And if you're shy and don't want your name out there, you can send me an email. Just go to my GitHub account and you'll see my email address there and send it to me directly. I appreciate you taking the time and watching this video. I hope you were able to learn a thing or two. And I think that's the end of this. I look forward to seeing you back in my next video. Take care.